Welcome in everybody to another severe weather discussion. In today's video we'll be discussing the severe threat across the prairies for Friday all the way into Sunday. Starting with the maps here, or with the visible satellite, we can see the biggest wrench in the forecast here will be the wildfire smoke that will exist across the region. We can see those very powerful southern BC fires. You can see pyrocumulus in the satellite imagery here, as well as just a bunch of smoke being thrown into south central Alberta, into western Saskatchewan, as well as the fires moving in. See if we can change the sector here. From the Northwest Territories and Yukon, those are getting dragged back behind this system, which is currently producing severe weather in the northern Saskatchewan. But yeah, overall, as well as the Oregon fires that have popped up. But overall, the fires, the smoke from the fires could throw a wrench in the forecast here. And we could see from the BC Wildfire Service just how many fires are out of control, and your main ones being the big ones being the Boston Bar fire, and we could see evacuations all along the river here, with multiple very intense wildfires and multiple out of control wildfires in southern BC here. So that will definitely throw a wrench into things. But looking at Environment Canada's outlooks, so far we only have for tomorrow, but we can see here for the Prairie provinces into southeastern Manitoba, we could be seeing the threat for tornadoes. They highlight two regions here, A and B. Both have tornado potential, with A being different, with hail size, rain, and possibly tornado intensity or frequency. And we could see into northwest Ontario here. We could see they have a high risk here, and this dashed line kind of extends eastward from the dashed line in southeastern Manitoba there. Overall, I think we could be seeing tornadoes further north as well. But definitely, I think this environment deserves a high risk. So it'd be a pretty powerful system that will move through. Currently, that system that's in northern Saskatchewan will be the big weather maker for tomorrow. And we can look at the GEFS probabilities, and we could see very high probabilities for northwest Ontario, 2% and 5% extending into pretty much near just south of the Winnipeg area. And overall, it could be a pretty active day out there just for the southeast Manitoba corner, and then into much of northwest Ontario, even in the more populated areas like Kenora and Dryden. Overall, the tornado threat that extends northeast shouldn't be too much of an issue, just because not too many people live out there. But yeah, overall, it would likely be a very active day with multiple tornadoes in that area that will hopefully not hit anything. But we can look at how the wildfires will evolve next. Taking a look at fire conditions here. This is from the European. We have 500 millibar height anomaly on the left, with 500 millibar geopotential height contours. And on the right, we have 2 meter temperature, surface temperature. And we'll just animate this forward. And we can see lots of high falls coming in. Quite a bit of cool air in the Northwest Pacific here. BC coast, and strong jet stream bring lots of precipitation into this region, and cloud cover. It could bring with it some strong winds as well. But here we have relative humidities and precipitation totals, and we should start seeing those humidities start climbing, and precipitation totals start climbing into southern BC here over the next couple of days. Though the same can't be said for Oregon. The Oregon fires completely. Lots of that precipitation missing out for Oregon there, and I'm sure any other favorable forested areas in southern Idaho or western Idaho could start lighting up as well. Um, but overall, it looks like the conditions will be favorable for the fires to decrease in intensity over the next couple of days here, which is a very good thing. Um, go back to temperature here to see how it evolves. I mean, this is 190 hours out, so the long range pattern we lock in here is I have this very strong uh, uh, jet stream in the Pacific Northwest here. Um, and some of that ridging will make its way into southern BC again through the later weeks. Again, this kind of subtropical high here that extends all the way across the Pacific and into the Atlantic is being reinforced over the four corners here. So this pattern will likely persist for a long time, and we could see we had this very kind of cold bowling ball of air and multiple cold pockets move into the Pacific there. So hopefully we'll start seeing a slowdown of the southern BC fires because there's lots out there. But it looks like the Oregon fires might keep going. I mean, we could see temperatures will be very hot out there. Humidities will be pretty high. It looks like the majority of the rain from the strong jet stream will probably miss out where those fires currently are, and some ridging to come for northern Saskatchewan as well. You can see quite a few rounds of that. So the North Saskatchewan fires will probably continue as well, and into Northwest Territories. Very cool pocket comes in as well, and we can see it kind of sits here. So overall, fire activity across BC and Yukon should start to quiet down. We can look at precipitation totals from the Euro for the entire period here, for the entire 360 hours. Hopefully this loads here. And we see quite a bit of precipitation in the mountains here in Northwest Territories. Quite a bit for northern Saskatchewan and where those fires are. And not a lot for Oregon, so we could still be seeing that smoke from Oregon as we have the southwesterly jet stream keep advecting those winds in, and unless they can really control those fires out there, I don't see them slowing down anytime soon, and hopefully more precipitation to come for southern BC because it desperately needs it down there. But yeah, overall fires will likely be an issue over the next few weeks and will likely mess with severe weather chances. This weekend, the smoke will likely be advected across most of the target areas. So you're going to need every bit of forcing that you can get, and any bit of shortwaves, lift, just anything you can get to overcome the thick smoke, limiting destabilization. But we'll move on to the forecast models next and break down the severe threats over the next 3 days here. Moving on to the severe threat for tomorrow. We'll start top down. We'll start the 500 millibar chart. We can see the current wave. This is the 12-0. That's over northern Saskatchewan. We'll move almost due east, maybe a little bit southeastward, and pretty strong flow at the base of the trough. It remains pretty much neutrally tilted through most of its lifetime, and it will be kind of sucked in to the backside of this upper Hudson Bay vortex here, and see some of that energy will be hitting northwestern Ontario in the afternoon hours. And overall, just strong broad flow aloft. Still have this ridge here that extends northward, but we kind of break it down with some high falls. Actually quite a bit of high falls into southern Manitoba. We can look at the GEFS for the high tendency here, and I'll go back over to Friday. And we can see through most of the day we have high falls across the target area. Most of that being further north. Taking a look at our dew points here, we can see a very broad warm sector available. Very high dew points for being this far north. You can see mid 60s all the way north here, and some sort of frontal feature, warm front like this, low and cold front. Looks like something like that. Yeah, looks like you have something like this. So quite the broad warm sector out here. This is for, I guess, early in the morning. You can see maybe some sort of front, cold front, and pours down here later into the afternoon, and that could cause things to go into a mess there if it's pretty strong. But overall, lots of lift further north. Most of your strongest lift will be further north, and more subtle lift further south. And quite the warm sector here. We probably have a low-level jet associated with this moisture here. Very strong, 38 knot, even stronger, up to almost 50 knots moving in. Have to remember this is Northwest Ontario, so 18Z would be about, I believe it would be at least 1 o'clock, maybe even 2 o'clock. 6:21. Yeah, so they're an hour ahead there. So yeah, peak heating will be at about, I don't know, about 2:30 into, it'll last a decent amount because you're pretty far north up here. So yeah, this low level jet kind of hits further east, maybe a bit with your heating there. We can see our fronts in the vorticity field. See that main one up near the Hudson Bay coast. I wonder if you get moisture up along the coast, that would definitely be an enhanced area of low-level shear there. You see, yeah, quite a bit of shear up along the coast and that frontal feature, southeast storms. So if you get anything to ride along the coast, that'd be interesting. But looking in southern Manitoba, again, we have these broad high falls, maybe two kind of jets extensions here, or jets merging here. Can have a split flow, stronger flow with this ridge here, and then look even further up. Yeah, quite a bit of strong flow aloft, moving in from this kind of southern extension of the ridge here. See our kind of long wave trough extending all the way from this Hudson Bay low and southwestward like that. Yeah, overall the synoptic scale jet definitely favors supercell development. Subtle lift through southern Manitoba out ahead of the front through most of the day. Warm air advection. And overall, it looks like a pretty decent environment. We'll take a look at soundings now. We'll move to the 18Z NAM. Put on energy helicity index. See it lights up pretty big there for southeast Manitoba. But this would be out ahead of some sort of front. And we should probably look at 700 millibar temperatures. Might be advecting some of this warm air into southern Manitoba, so southeast Manitoba could be capped. And I think that's the reason for the slight risk down there. Is your window for storms will be quite small, and you'll likely be battling a cap down there. But subtle forcing into the daytime. Could break that later into the afternoon. You see, this is quite the sounding. Pretty strong wind aloft area. 10 knots at the surface to about 50 knots at 4 kilometers there, which is pretty impressive. 700 millibar winds at about 20 or 30 to 35 knots. Yeah, so quite the low level wind field for this region. You can maybe draw our fronts here at peak heating from the NAM. You go for 3 o'clock here. Going to have a sharp gradient here, and then it gets kind of diffuse for the south here. Might have like a double front kind of feature in here. Maybe some sort of like dry line feature. And just lots of warm air advection into this region. And take a look at bulk shears. I don't believe Weatherfront has bulk shears for the NAM, but we can kind of guess with our flow up here, and yeah, pretty perpendicular component down there off that front for most of the risk area. So yeah, a very large warm sector. I think the better environment is further north. The GEFS picked up in southwest Ontario. And we can see as we move later into the evening, your low level jet starts to crank up there. So yeah, storms that develop will definitely become stronger in the evening, just with that low level jet. And during the magic hour there, as your photographs increase, you decrease turbulence in the boundary layers, so the winds just above the surface will increase in speed, as well as the more moist air to the east, cooling a lot less, so you get a thermal gradient, or a thermal driven pressure gradient with stronger winds in the warmer moist air, and maybe a dry line feature on the NAM here, or at least some sort of mixing gradient. Look at the wrap, even though it's not a long range model. Let's look at 3 Cape to see. I like to use 3 Cape as a proxy for cumulus field development. You know, where's your low level destabilization occurring? And we can see it's pretty high in northern Ontario or northwestern Ontario. There are 700 millibar temperatures. Again, from the NAM here, or from the wrap. Cooler temperatures are up north, but they will start to move in through southern Manitoba later into the afternoon. So overall, I think there's a good chance you'll break that cap down there. You can see your 3 Capes really start skyrocketing. The wrap does tend to overdo it, but it's pretty nice sounding. Any storms that form north would be directed towards the Winnipeg area. So Winnipeg will definitely be under the gun tomorrow for these storms that develop. And honestly, this much 3 Cape, just a sign of low level destabilization. Again, you do have to consider the wildfire smoke that will be pulled in northward, and maybe 700 millibar winds would tell a good picture, and the smoke that comes in through this flow pattern will definitely be a factor as well. So if you get cumulus fields in southern Manitoba and the smoke isn't too big or too much, I definitely think it could be a high risk environment for tornadoes down there. I guess we can look at precipitable waters. And you have pretty perpendicular bulk shears, less forcing further south. So I think you would be likely to see a more discrete mode further south. But again, You have perpendicular shear across most of the front. So less forcing further south, so I think less messy. You can look at back to the ECMWF. Let's look at the AI just to see, just kind of smooth these features out here, see if there's any short waves early on. Might have, not sure if this is associated with a front here. Kind of your thermal front here. I'd say your front might be just a little west of the pressure trough here. Yeah, maybe some sort of vorticity feature, like it's elongated here, and might provide some steeper lapse rates above. We can look at 500 millibar temperatures. Maybe a little shortwave there, moving through. It's hard to say for sure. 700 millibars, maybe shortwave further north. Some energy moving in. It's hard to say for sure. Maybe look at the NAM. It's pretty consistent on that. Moving in the morning hours. I wonder if there's any instability associated with that. Maybe some mid-level. Definitely a warm air advection zone here. You can tell by the photographs. Let's try to break down the vertical structure of the atmosphere. These fields, these humidity and vorticity fields with thickness and pressure are really nice at just breaking down, kind of the vertical structure of the atmosphere, and we can kind of track these features as they move along here. Lots of cloud cover moving into night. So if they kind of see it here, a bit of a short wave, and the thermal gradient that merges with this front here. Warm air advection across this region. You get kind of a frontal wave in south central Saskatchewan. Something like this. Something like that. Moves into central Saskatchewan. That energy will be moving into western Manitoba there. And some of that lift will be moving in. We could see it early morning does have some activity associated with it. Yeah, so it looks like that vorticity feature we were seeing before is associated with this front that's further south. It's kind of secondary frontal wave, and lots of thermal advection out ahead of that. It's kind of hard to define a warm front. Might have a pressure tongue here. I don't know, maybe a warm front like that. Secondary frontal wave with lots of warm air advection early on in the morning. So yeah, you'll likely have some activity moving in early in the morning, and that would have to be a factor into how storms evolve in western Ontario here. Didn't really take a look at photographs out there. Just given the synoptics, I think I can expect what they look like. Pretty strong southwesterlies. Even just you don't have crazy curvature, but just the difference in wind speeds kind of induce a kind of pseudo curvature out there. That's what called Z-NAM. Might as well just throw an energy helicity index. We can see under this low level jet here. I mean, that's just an insane photograph. Compared to your mean wind, this is definitely like a mothership profile. Storm motions are pretty fast, 35 knots. Mean wind is about west easterly or due westerly at about how is that 50 knots. Pretty interesting. I don't know. It's a bit weird. This is definitely probably near. It's definitely in a warmer advection zone, so it might be messy. Let's look at your LCLs out there. If your LCLs are low, they're decently high. Yeah, if your LCLs are low, you'd probably have something you see in the southern states, where you have like these small bean storms pop up. But I don't think that would be the case here. Again, your forcing is weaker down here. Maybe it'd be a little bit capped with that warmer ridge air. It might just be the perfect amount of capping to get discrete storms. I'll move this back here. But yeah, like lots of cloud cover to move in with this frontal wave. The frontal wave could concentrate smoke with it as well, so that could be a hindrance and lead to your storms being focused on the front. Yeah, overall, a very dynamic environment. Quite the tornado environment for southwest Manitoba. Could see when do those three capes start to light up? Wonder if we could see if there's a chance for prefrontal storms out there. They first kind of start lighting up around 19Z, so 2 o'clock for the east. With the forcing and the destabilization, could be seeing prefrontal storms, especially any activity from the morning that gets reinforced later. I can see, I mean, your main front is further west here, and we can see activity from the Euro being just out ahead of that in this advection zone. And the shortwave here, 500 millibars. Maybe this might actually. I think this is an elevated front. Let's go back to the Euro. Definitely think it is an elevated front. Yeah, so I do think there's a good chance we'll see prefrontal storms that evolve just with this lift out ahead of your main surface cold front, and then development could occur behind that along the front in the southern Manitoba. Then your cold front really starts to push south with very low thickness values here. I wonder how cold this would be. Probably close to below 0 degrees. 42 degrees. So that's pretty cold air. That moves straight southward. So quite the cool down there. But yeah, could be messy in the morning. Just going off the Euro here. Likely see prefrontal storms. Let's get the HRDPS going up. I'll likely be able to use some other of the convective models as well. You can see it goes with some late night activity with that wave there, and then lots of activity just east of the border here and further north. kind of the HRDPS kind of keeps things capped further south, but there's definitely a chance that you could break the cap out here. And I think with that destabilization that the ramp was hinting at, as you break down this ridge, you'll definitely likely be seeing earlier prefrontal development. So yeah, pretty interesting day for tomorrow. Could definitely see a tornado outbreak. Good thing it's not in populated areas though. I'm sure the Northern Tornadoes Project will find quite a bit of tornado tracks through the trees here, tornado damage paths. Further north, I'd say you're more certain to get storms. But there really isn't a lot of people out here, so which is a good thing. So no one's going to be seeing these storms further north, but just with that front out there and stronger forcing, if you do get smoke down here, your main event will be north if smoke kills things further south. We can look at the wrap, just taking a look at smoke cover expected for tomorrow. And we could see quite a bit of concentration across most of the area, especially kind of along your fronts here, and where we have that deformation with that vorticity, kind of elevated frontal feature as well. So yeah, I mean, I think you're forcing being further north. This pocket out here could be pretty interesting, and of course your main threat. I don't know. I can honestly see them going for an extreme risk for Southwest Ontario, but I don't know. Just with the smoke, it might be too uncertain to go for that right now. But yeah, they may go for it, especially in Southwest Ontario, where you have Kenora and Dryden, and some more populated areas along the highway here, especially if things uptrend to storms firing earlier. I mean, I guess we could take a look at the HREF for probabilities. Just stir up tornado probability and updraft helicities. See at 22Z. Look where it's going for the front. Yeah. I don't know. It's a weird frontal structure further east. Definitely some sort of elevated feature, that wall. That comes from the frontal wave that moves through first. Because your front, let's say your surface cold front that you could define just looking at the broader. I think, do we have precipitable water? Might be easier to see it in this field. I would argue that your main front is further west. But nonetheless, you'll have lift and thermal advection associated with that feature eastward, so it will be interesting. Maybe take a look at the HER 18Z. Yeah, it could be a mess. Again, you have that low level jet, high precipitable waters. The front orientation is good. Yeah, but it all depends how things evolve. I could definitely see a solution like this. I bet you the NAM3K goes pretty crazy just from its cold bias with complexes that develop. Yeah. You can see it picks up storms firing just off the lakes there along that 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 I would define to be your actual cold front that comes in later, and this prefrontal stuff in your warm air advection zone. Yeah. But overall, what you tend to see, and I don't really see this discussed a lot, but when you have rain cooled air that rapidly modifies. I mean, rapidly. You'll see this happen with an early convection move, and oftentimes the area that was forecasted and maybe a bit further west doesn't start to look as good because you'll have rain move through, and then it will deposit that moisture down there, and it really starts to modify with that rain cooled air just above the surface, and you tend to get very large cumulus fields. So if this rain can modify and you get really bubbly cumulus in southwest Ontario, then I think we could be talking a definite tornado outbreak out there. Um, Again, it's hard to say with the probable smoke cover that will be down there. Um, and again, possibly affecting that cap, that warmer air northwards. Could keep things capped if it's not modeled very well. Yeah, might remain capped further west. Yeah, you can see. Look at the difference: 18Z, 20Z. You rode that cap pretty quick, apparently, according to the NAM 3K. Let's look at the RRFS. How far did this go? 84 hours. Yeah. So if you get prefrontal storms like what the NAM 3K was showing, things get pretty hairy for the populated areas in northwest Ontario. But it looks like that cold front is more certain and is well further north, where I think your most dangerous storms would be probably further north. But yeah, it could be an interesting day tomorrow. Hopefully, tornadoes stay away from Winnipeg and more cities and populated areas. Hopefully, they're just in the middle of nowhere and don't throw out lightning bolts to cause more fires. So, yeah, it'll be a pretty interesting day. And yeah, we'll move into Saturday and Sunday's threat. They won't be as accurate just because, well, Saturday is 2 days out and Sunday 3 days. So we'll just kind of do a surface level breakdown of those threats and just the larger scale features because that's all we can really predict as of now. So we'll move on to that next. Taking a look at Saturday's severe threat, it looks like the Alberta foothills will light up again, possibly in the southeastern Saskatchewan, southwest Manitoba. But I think it's a lot more conditional just because this ridging out here and the general subsidence aloft. Saturday may struggle a bit, again, if those fires continue, which I don't see how they wouldn't be just given how powerful they are. That smoke will be advected into this region here. But overall, I'm really liking what I'm seeing in terms of the dynamics. If the shortwave was just a bit earlier, or into the early afternoon hours, then there would probably be a lot more of a favorable environment. We can go to the GEFS for height falls, and we see they're not very strong through most of the day here. Maybe just confined to further northwest Alberta here, west of Highway 16, near Jasper. We could see here at GEFS, you definitely have enough flow for supercells, 300 millibars. see height falls there. 200 millibars, yeah, definitely a strong flow out there. Look at precipitable waters, and we can see it pools kind of west northwest of Edmonton with that dryline circulation. Um, that tends to develop in the foothills. The foothills vacuum cleaner trough will likely be active in the QE2 corridor, or just west here, just northwest of Calgary. And we can see those northeasterlies really extend here into the evening, where your tornado potential will be the greatest. But right now it's looking like just kind of a classic Alberta supercell environment. Forcing won't be crazy strong from larger scale synoptics, but you'll have maybe just subtle divergence aloft, subtle defluence over the foothills. Again, the foothills themselves will provide some divergence. As the flow goes over the Rockies, it will hit the tropopause and diverge on the tropopause, and you get some divergence downstream of that. And in the wintertime, if it's strong enough, you typically see cirrus streamers just at ahead on the foothills. But you kind of get two areas of vertical motion. You tend to get one downslope component and then one in the upper atmosphere kind of upward vertical motion up and over the Rockies. And you have the Alberta dryline circulation, which its mechanism is very well understood. You have, sloped heating, which the Rockies heat up faster, so you have you heat up the air there more. You get lower pressure. You'll pull in air, but you also have mixing as well at the leading edge of that. And of course, in the QE2 corridor, where your terrain, or just west here, your terrain switches or changes the most abruptly from Rocky Mountain to pretty much prairie elevations. You tend to favor cyclogenesis out here, and the dry downslope air kind of meets with the warm moist air that's pulled in from the northeast, and you kind of develop a dry line there. But it's just a well-known phenomenon that happens, even if the regional models and even the high-resolution models don't hint at moisture being high. If it's downstream, which it likely will be, just because of the rain out there, as we have seen on I believe July 16th and 17th, where we saw 2 EF2s on the Friday and another big tornado near Rocky Mountain House on the Saturday, on the 17th, I believe, or the 18th. 17th and 18th saw 3 tornadoes in your northwest Calgary area. And the models really weren't picking up on moisture being very high out there, but you had your moisture pooling happening in the foothills, and your dew points on Saturday were almost as high as they were in the extreme risk, which was further north of Highway 16. Dew points pooled all the way up to the high 60s out here, when I believe the regional models in the morning were only showing I don't know, a low 60s at most. So just given all the moisture upstream, you can never underestimate the foothills to pull in that moisture into the evening hours. So especially with maybe just a little more subtle forcing in northwest Ontario or northwest Alberta earlier, you can see from the GEFS the 0Z to 6Z period, the shortwave ejects. So from 6 p.m. onward, that shortwave will eject. So it might just be a little bit mistimed from your destabilization, but it will likely be perfect timing with your moisture wash back into the foothills. So further north, I think, would be earlier with storms, and if storms fire into the evening, 6 o'clock onward, from the shortwave, honestly, those could be pretty interesting. Uh, GEFS shows lower moisture further south, but I don't know if I would trust that very much. Again, just going off of, you'll probably have northeasterlies. Let's look at the wind. Cyclogenesis developing north of Calgary, west of Red Deer. From the GEFS, the best tornado environment looks south of Highway 16, west of Edmonton. Honestly, kind of a similar environment to July 31st, 1987, the Black Friday tornado. We could pull up the environment sounding for that. I believe the Euro was showing kind of similar photographs out there. Let's look at 3Z here. 0Z. You can see those easterlies at the surface. I wanna find where more northeasterlies under this moisture. Come on. And yeah, anywhere where you pick up more curvature, maybe even out here. But overall, this area does look pretty nice. See, the tight gradient here develops further west. Maybe we can look at an Alberta topographic map to see where cyclogenesis would be favored, just based off of the terrain difference. See, the strongest fall off in terrain is north of Calgary. Second fall off, strongest fall off looks to be, where would this be? It's near Nordegg, north of Nordegg. See, maybe it's a little less gradual here. Maybe more of a stronger fall off for out here. I mean, anywhere really, you'll get cyclogenesis, but it looks like, I don't know, you could see a local backing of winds. You have a terrain feature here that might kind of spiral your wind cyclonically. Just north of Highway 16, north of Edson. You can see, it's hard to say. Maybe look at, GEFS was showing, maybe look at 925 millibar height. It mainly shows, it really shows a trough along your foothills here with your dry line across most of it. So, your higher moisture is further northward near the Edson area and eastward to Edmonton. Let's look at supercell composite. See, I actually want to compare runs because I believe this might have trended a bit. It's pretty much along Highway 2 here, but I think your higher chance of storm development. I don't know. Let's look at 700 millibar temperatures. ECMWF. Your cooler 700 millibar temperatures will be coming in from the northwest. Z0Z. But again, you'll have that short wave that might just hit at around just past 6 o'clock, where you still have instability left. And yeah, it's looking like maybe northwest would have late afternoon storms first. Yeah, we can look at the again the kind of structure of things here. The mid-level humidity, the thickness. You can see maybe a frontal wave in BC. See, hard to find this low pressure here. Some sort of cold front along the west coast. Here's 21Z, 0Z. You can see some of that cooler air starts to move southeastward. Further northwest, that's quite a tight thermal gradient here. Maybe an early shortwave ejecting here. Let's see 500 millibar vorticity. Maybe go to 700 millibars. Yeah. See, the Euro does pick up on stuff firing in this kind of bear clinic zone here. This would be before your main supercells. You can see the shortwave gets close. You have further development just west of Rocky Mountain House. Yeah. Overall, looks like most of your stronger lift will be coming in. Further northwest, you can see it in the relative humidity field. Like the frontogenesis. Put this on here. Early on here, you can see the thickness gradient kind of flows through here. Let me put on 700 millibar temperatures in the GEFS. Where is it here? There it is. Yeah, you can see, especially later into the night, you get those cooler temps moving in. But further south may be conditional. Again, it depends on how much moisture is actually down there. Take a look at the RDPS. Actually, I believe it's on here. Maybe the RGEM. It's like a dew point. See, the RGEM does have stuff, moisture further south. They put on where it shows 500 millibar contours here. See, it doesn't really have the definition of that shortwave as much, but it does show up on the GEFS, so it'll likely be out there. Yeah, if you get sufficient moisture pooling, even under the stronger flow, you can see you will have stronger flow, just barely impinging north of Calgary here. So yeah, even though you have maybe even height rises down there, they don't look to be significant. If just neutral, height is barely changing at all. So yeah, generally it looks like this area for Saturday will kind of be a classic supercell environment for very large hail, strong winds, and further northwest looks like could be a tornado environment if you get enhanced northeast winds in this corridor here. I don't believe the GEFS from the ASTOR. Let's see, this is 12Z. Let's go be 25th. Doesn't highlight any tornado potential out there, but I could definitely see the GEFS trending the tornado potential further north, north of Highway 16 in north of Edson. If you get those enhanced northeasterlies and enough moisture without too much messy storms coming from the northwest, but then you have that short wave to the south that might just come in right at the perfect time. We can look at your low level jet. Let's look at 850 millibars. You can see from the Euro here. See a cold front. Looks like it might build up against the mountains here and then push south. So things could get messy northwest. Might just have a short window for storms further northwest. And then things would go upscale and you might get your classic 100 kilometer an hour supercells that have the massive hail swaths in kind of north of Calgary and eastward. But it looks like moisture quality will be lower further south, so I'm not too sure about that. Let's look at the RDPS. So we got dew point. Take a sounding 21Z. It's going to be on the QE2 here. Probably have pretty nice photographs out here. And pretty much due easterlies. Showing a bit of a cap there. Let's look at the surface. I mean, actually really nice shear out here. Look at this. I think the models are underdoing the northeasterlies. I know I picked a sounding from the Euro that looked very similar to the Edmonton tornado 1987. Again, I'm not going to say a tornado of that caliber is going to happen because that happened pretty early on. It doesn't look like it looks like your storms are going to be later into the evening, just going off of how early your lift will be. And again, potential smoke cover to consider as well. But I believe I looked somewhere in maybe this area here. Yeah, you can see doing the northeasterlies at the surface, and this is a pretty similar environment to the what you call it. I mean, the 1987 Edmonton tornado did have maybe quite a bit of curvature. Again, the Euro here isn't going to show that much curvature. We can look at the NAM. I want to see how it trends on storm outlet velocities. Doesn't really pick up maybe into the evening here. Oh, it's very similar. I'm gonna pull up the Edmonton tornado sounding, and we'll compare and contrast these environments here. Here is a look from Storm Chase Archive. This is a great website if you want to ever look at previous environments. This looks like ERA 5. Not sure if this was a model of the past or an actual observation. Pretty much a due southerly jet. Strong jet, but relative to the upper level winds, you had easterlies. So if we have a southwest jet, or we had winds to the right, or to the I guess due south, you had southeast winds relative to that. So if we have southwest winds and the northeast winds relative, let's draw it out here. So here's Edmonton. Winds are looking something like that. And then here's what Saturday's gonna look like. Pretty much west southwesterlies this, and then see, maybe east northeasterly. That's the surface. I'll get rid of that. Something like that. So we kind of rotate this around. You can see it's a bit of a different environment relative if we kind of shift our vectors around and kind of shift the photograph. So not exactly the same, but yeah, yeah. Maybe comparing it to the Edmonton tornado environment isn't the best. Definitely not. The orientation of your jet was quite different, and even your low level winds relative to your upper level winds were quite a bit different as well. Mixed layer Cape 2800, a little lower maybe from the NAM here. But overall, this would be an environment supportive of tornadic supercells, especially picking up enhanced surface vorticity out there along any cold air dammed accelerated cold fronts in the mountains here. Again, we saw that tight thickness gradient, tight temperature gradient. So any southeastward moving kind of cold air pockets could develop, as you typically see in the foothills. NAM is showing subtle height falls, maybe a more broad, kind of subtle short wave feature, almost a long wave here. That might, those height falls definitely favor. Oh, this is into Sunday here. Yeah. That's okay. Let's look at this. Was I looking at the wrong day before? No, I wasn't. Okay. Yeah, pretty nice soundings from the NAM. Does show maybe a little residual cap there. Let's look at previous runs. Maybe quite the uptrend here. Look at 12Z. Yeah. It's really just really anywhere where you get those northeasterlies that develop. I would say it'd be favored in this kind of area here, just from your stronger transition with the change in elevation. NAM shows a frontal zone. I wonder, let's go back here. Is there actually a front out here? It might be. Look at this. Interesting. Its vertical at depth doesn't look crazy. On a lower level vorticity here. I don't think it's very sloped, so I don't think you're going to be capped north of this feature. But this might be a warm front. I don't know. This is it's hard to define it for sure. Maybe look at theta E. That might be definitive. I mean, moisture pooling north of that from the NAM. Look at the Euro. Exactly what this feature is, I mean, I'm not 100% sure. Kind of looks like a warm frontal feature, I guess. Yeah, I would say that's what you would define it as. Let's go look at a Euro sounding. Yeah, maybe just a might act as a mixing gradient. Will you get storms further east? That's a very interesting. Dew point profile not mixed at all. Dew points decrease very rapidly above the surface. I don't know if the NAM accounts for smoke in the model, if it tries to propagate forest fires, or just currently takes the current smoke conditions. But yeah, I'd say overall this pocket further west is looking more favorable. Could get further south, north of Calgary into the Highway 2 corridor here to Edmonton. Possibly further east as well. But your GEFS highlights kind of further north here as well. High thunderstorm development probabilities further north, and chance for significant hail. It doesn't highlight tornado potential. It usually doesn't pick up on these foothills tornado events, as they kind of seem random. Usually, if your dew points are high, you get tornadoes out there with your supercells. It's really just a game of, can we get low enough LCLs to get your mesos on the ground, because you typically have boundaries that come off of the hills. The terrain is very rough in the foothills here, so you just have lots of vorticity at the surface. So you get a mesocyclone close enough to the ground, and you typically get a tornado out there in the foothills. Sometimes you also get very tall tornadoes. Didsbury was an example of that. So, I mean, there's something about the foothills themselves that allow supercells to produce tornadoes by themselves, and you typically don't need storm interactions like you do with most tornado setups to get tornadoes, like you do in the high plains and eastward into Saskatchewan. But yeah, overall looks pretty good, pretty nice environment for supercells. As we can take a look at, I'm gonna look at your hail growth zone Cape. Yeah, I mean, you get isolated supercells in this environment. Definitely have large hail, as you typically get in the foothills. So yeah, large hail is definitely a possibility. You'll likely have discrete storms just with orientation with the jet. Smoke could be an issue as well. But yeah, could see this being a high risk environment if things keep trending upwards. Even if the GEFS can pick up on those tornado probabilities, you might see tornado probabilities in the foothills from this here. So yeah, pretty solid supercell environment. If forcing was just a bit stronger, I'd say it'd be more certain, especially further southward. But things could get messy. Looks like your low level jet will be focused southward, so maybe north might not get messy. It's hard to say because sometimes you just get boundaries that get thrown out. Let's take a look early, see if this is mixed boundary layers, inverted V profiles. I mean, you have pretty dry air up here, so could get boundaries thrown to the south from storms that fire. See frontogenesis picking up early northward, 18Z here. Further north. Yeah. Look at the topographic map for northward or northwestward. I guess the terrain shifts quite a bit. It goes 1750 down to 703 meters, so yeah. Could get if you get moisture pooling northward earlier underneath that Cooler 700 millibar temperatures. You'll likely see earlier storm development in north near Grand Prairie. Um, that could mess up things further eastward. It's hard to say. And your subtle height falls. Looks like they'll be further northward. You can see the RDPS. RGEM looks like it tries to fire storms there as well. And RDPS. Look at that environment out there. Yeah. You can see that destabilization hitting northwestward first, so likely see your first storm development further northwest out here. You can see the GEFS picks up all the way from 15Z to 9 o'clock in the morning earlier. And then things move eastward, possibly to the Edmonton area later into the evening and nighttime. So, yeah, Edmonton might have to watch out, especially because your northeasterlies will start going after about 6 o'clock into the nighttime there. So, and just given all the ground moisture that's down there, your LCLs are likely to be lower. So, yeah, I think tornado potential will exist for Edmonton. Smoke permitting, of course, just because we can see the spread of the jet stream here. Your Oregon smoke looks like it will be invected down here. Southern BC smoke, if the fires are still as strong, could be invected into the region. But yeah, could be an interesting environment. And definitely non-zero tornado potential if things keep looking like this for Friday. And also just quickly discussing the Manitoba threat in eastern Saskatchewan. We can see for Saturday here, it does show some probabilities, but that ridge will likely keep things from forming out there. Just take a quick look at your forcing and a couple soundings. Let's look at the Euro here. Sunday. See a nice dry air loft moving in. But again, we still have this ridge. More of a breakdown on that ridge. And you can see nice 500 millibar kind of vorticity lobe here. Quite a bit of forcing will move in. Let's look at GEFS. You can see subtle height falls coming in further north. So we saw the thunderstorm probabilities further north there as you get height falls out there. So yeah, looks like sorry, this is for Sunday, Saturday. Yeah, might be on the edge of a warm front. Kind of see the wind shift here along a warm front further east. There are a couple of soundings out there. Yeah, it looks like you'll probably remain capped. Look at the 18Z NAM. The NAM does show you becoming uncapped. Good bulk shears. Um, yeah, but you may just struggle to get storms out there. Maybe a little bit of cooler air. Just on the north kind of side crest of this ridge. See some warm frontal vorticity. And yeah, not a bad environment out there. Look further south. And that's pretty crazy down there. For southern Manitoba. Just your synoptics don't really favor storm development down further east. See if we have like any signal for dry line down there. See maybe a little surface low. Take a look at the Euro. Yeah, so quite the difference there. Yeah, so we'll have to see how southern Manitoba evolves in southwest Manitoba. But might have a little frontal wave just barely at the surface there for Saturday evening. There's lots of moisture as well. So could have thunderstorm development. Pretty interesting profiles. Southeast moving storms. Pretty interesting photographs. Very long photographs. Really big hail photographs. High mixed litter capes. Yeah, might have some sort of frontal wave here. Yeah, but probably lots of warm air advection down here. That would be your main driver. Warm air advection and thermos along that warm front. But yeah, you'll be lacking lots of upper level lift. So yeah, overall the threat favors the foothills, but something could develop underneath these cooler 700 millibar temperatures further north here. Take a look for 3 o'clock. Yeah, pretty good sounding out there for supercells. I'm just quickly going over Sunday severe threat. We'll just start with this map here. You can really see a nice dry punch moving in as you move into the afternoon. You have the 500 millibar Vort lobe here. Surface low, cold front southwestward, warm front. Maybe previous thunderstorm energy from the foothills moving in and kind of reinvigorating into the afternoon. I could lay out a boundary in southwest Manitoba. Yeah, but I really like this dry air loft here. Your ridge kind of starts to break down there. Where's GEFS? Good. The heights aren't loading here. Anyways, we can see some height falls coming in for Sunday afternoon across this area. So it's looking pretty nice. Let's take a couple look at soundings out there. And just quickly going over this environment just because it's still pretty far out. So just briefly look at some environmental soundings. Sunday. See if this is along that warm front. The NAM has quite a different picture. Let's look at the Euro. synoptically, things look pretty nice. The Euro maybe is a little more broad with that warm sector. 18Z. It's looking right at the tip of the theta E axis here. 700 temperature. Yeah, let's look up here. Yeah. I don't know, I would say, let's look at, again, you still might have capping issues, but you'll have actual height falls and that frontal wave moving in. So I think your thunderstorm chances are higher for Sunday. It's like here, day 4. You can kind of see belt further north there. With your cooler 700 millibar temperatures, and you can see it extending to eastern Saskatchewan, western Manitoba there. Yeah, lots of energy out there. Definitely very high dew points. Yeah, could be pretty interesting. I like the look of the upper levels. Definitely kind of screams supercell outbreak. If all the other ingredients come together, because that's quite a nice breakdown of that ridge for the region there. Yeah, that's a pretty nice photograph as well. 71 degree dew points, 84 LCLs, just around about a kilometer. Drier aloft there. Good bulk shear. 54 knots. Everything screams supercell outbreak from the Euro. The NAM doesn't. We're on 18Z now for the Euro. Let's look at the trend here. Let's look at 12Z. Looks pretty similar. Maybe more cape on 18Z. Yeah, pretty similar. It's definitely a nice looking sounding. Still might be slightly battling with that cap, but you'll have the forcing coming through. This feature could be messy. Let's look back to here. Let's go up to 18Z now. If that's associated with dry air, just along this frontal feature, could be interesting, especially with those cooler 700 millibar temperatures, which is where the GEFS kind of shows things. 700, 300 lapse rates, 3 capes. I don't know if the ECMWF probably doesn't pick up on 3 capes that well, but yeah, it's kind of pocket. Eastern Saskatchewan, maybe see kind of Hudson Bay, Porcupine Plain, Green Water, eastward into Duck Mountain. Could be the danger zone for Sunday. But if things evolve like this, it would be quite the environment. I don't think I'd be able to chase it just because I'd have to work Monday morning. Wonder if I can load up the GEFS. Doesn't look like I can load up those fields on the GEFS. I wanted to see the mid-level humidities from that. Just pull up the NAM as well. See what it shows. Yeah, it is a lot more skinnier with that warm sector than the Euro. maybe it doesn't break down that ridge as much either. But your GEFS height contours aren't loading here. Load this up. Yeah, does look like you have high falls out there, so yeah, this area could be pretty interesting. I just look at the level jet to see what that's looking like. 18Z Euro. Yeah, pretty strong. So yeah, could see tornado potential out in this area as well. Definitely supercell potential. Kind of decent forcing. And pretty high dew points, so could see complex developing later in the night. But kind of a draw line feature here, maybe slight cold frontal feature. Looks like a dry line that could develop storms up there, but might be dealing with a cap further south, so forcing is better north. Coolest 700 temperatures in this pocket here could lead to supercell development, and things could uptrend with time or downtrend. But if we have that smoke for further south along this boundary, it could ruin those chances for sure. Manitoba escarpment could act as a thunderstorm mechanism, typically in this area here, in between, you know, Duck Mountain and Lake Winnipegosis. This area tends to throw up some mean supercells that tend to develop hooks in this region for whatever reason, whether it's an interaction with the lakes or the terrain features, I'm not sure, but this area tends to could be pretty active for supercells, and these terrain features could act as forcing mechanisms for thunderstorm development as well. So yeah, looks pretty interesting for Sunday. But that will do it for today's video. Thanks for watching. Definitely excited for more severe weather to come over the weekend and into next week. Looks like the foothills will keep lighting up into next week, just with a strong southwesterly jet, and hopefully the wildfires will calm down for southern BC. But that will be all. Thanks for tuning in. See ya.